Hi everyone, today we are doing section 11.3, which is labeled as vertex form. And basically what we're trying to do today is rewrite a quadratic function from standard form to vertex form. Okay, so just real quick, remember this is the standard form of a quadratic function. This is the format of a quadratic function in vertex form. To find the vertex in standard form, you have to do a little work. You got a little equation here. To find the vertex in vertex form, we can just identify h and k right away. All right. The vertex in standard form is still hk, but you have to use a little equation to find h. And then your k value, you plug h back into the equation for x to solve. All right. I kind of explained that right there. The axis of symmetry is just whatever the h value is. So again, here in standard form, you have to do a little equation, which you can get from doing it in the vertex, from the vertex. And then in vertex form, here you just identify the h value. All right. So here are the steps to go from standard form to vertex form. All right. I have an example already worked out just so you guys can refer back to it. So let's look at this equation here. I have f of x equals 3x squared minus 12x plus 7 in vertex form. Step 1 is to factor the leading coefficient from the quadratic in linear terms. So here's the quadratic in the linear term. So I'm just going to factor the leading coefficient out from those two terms. So when I take out that 3, I'm left with x squared minus 4x, and then I still have this plus 7 over here. Okay? Step 2 says to complete the square by taking half the linear coefficient, squaring it, and then adding it inside the parentheses. So we've already done completing the square, guys, right? We know this already. So my b term here is negative 4. So I'm going to take negative 4, divide it by 2, and square it. That gives me negative 2 squared, which is 4. So I'm going to be adding 4 inside that parentheses. Okay? Now, step 3 says to maintain the value of the expression, multiply the leading coefficient by the number added inside in the parentheses, then subtract that product, okay? The reason why we need to do this is to maintain the value of the expression. Technically, right here, I was just being a magician, okay? I wasn't being a good mathematician. So, to make sure we're being good mathematicians, we're going to subtract by the product of the number we used for completing the square and the leading coefficient. So that's this guy right here. Okay, and we're going to subtract by that term. And then you guys can simplify that. So that's negative 12, and then we have the plus 7 still. Then step 4 says write the trinomial that's inside the parentheses, so this right here, okay, write this, as a perfect square. We know how to do that. That's the whole reason why we did completing the square, right? To solve. And then it says the function is now in vertex form, okay, because negative 12 plus 7 is negative 5. So now that looks exactly what vertex form looks like up top in your notes. All right, so let's take a crack at it. All right, number 1, it says write each function in vertex form. So remember, your first step is to take out the leading coefficient from the quadratic and the linear term. So here's my quadratic and linear term. My leading coefficient is just a 1, so I'm going to take out a 1 here. I have f of x equals, right? Okay, so I'm left with x squared plus 6x. I'm going to leave a little blank, plus 11. All right, so now step 2 is to complete that square. So let me take the 6, divide it by 2, and square it. 6 divided by 2 is 3. 3 squared is 9. So I'm going to add 9 right here. Okay. Now remember, we now have to subtract by this value times the leading coefficient to maintain the value of the expression. So 1 times 9 is just 9, but I'll still write that out just for note purposes for you guys. Okay, so we get negative 9 right there. Now I'm going to go ahead and factor that trinomial. So that's going to be x plus 3 squared. Coefficient's 1. Negative 9 plus 11 is just 2. So my equation in vertex form is just x plus 3 squared plus 2. You don't technically have to write that one out in front. Just assume that it's there. Okay? Not too bad, huh? All right, let's do number 2. Again, you're going to factor out that leading coefficient first from the quadratic and the linear term. So I have g of x equals 5 times x squared plus 8x. Leave the little blank. Minus 3. All right, 8 is my b term. When I divide it by 2, I get 4. When I square that, I get 16. So I'm going to add 16 inside there. So I get 5 times x squared plus 8x plus 16 minus 5 times 16 minus 3. Remember, you're multiplying this term by the leading coefficient, okay? So we get 5. This is x plus 4 squared. 5 times 16. Oh, that's going to be a big guy. Whoops. Sorry about that. 80. Subtract that. Negative 80 minus 3 will give us negative 83. And that's your g of x function. All right, not too bad. Not too bad. Okay, number 3. It says write the function in vertex form, then identify the vertex, the axis of symmetry, the y-intercept, and tell which direction the graph opens. Okay, so let's go ahead and write this in vertex form first. So again, I'm going to take out my leading coefficient out of the quadratic and the linear term. So I have negative 2 x squared minus 8x, positive, I take out negative, that becomes negative, blank, minus 34. So I have negative 8 divided by 2, that's negative 4, square that, still 16. All right, then this gives me negative 2 times x squared, whoops, minus 8x plus 16 minus, my leading coefficient was negative 2. When I completed the square, I got 16. Okay, don't forget to subtract by that product, all right? So this gives me negative 2. Let's see here. This is x minus 4 squared, right? Yep. Okay, and then that's going to be negative 32, but 2 negatives make a positive. So I have positive 32 minus 34, which gives me negative 2 right there. So this is my function in vertex form. Now I'm going to identify the vertex and whatever else it tells me to identify. So my vertex is, it's so much easier to find the vertex in axis symmetry and all that once you're in vertex form. All right, so my vertex is the hk value, so h is 4 and k is negative 2. Okay, remember when we did absolute value functions, how we talked about the h value, if this is a plus sign, then that really would be a negative 4. Okay, same idea with quadratic functions. So there's the vertex. The axis of symmetry, I like to label as just AOS instead of writing it all the way out. So that's a line. So you need to say it's x equals, okay, that is a line. So it's x equals whatever the h value is, which is 4. So x equals 4. The y-intercept, okay, negative 2 is not your y-intercept, all right? I know some of you are probably thinking that. The reason why it's not, though, is because think about, like, up here, like, technically you can FOIL this thing out, right? You get x minus 4 times x minus 4, and when you FOIL that out, that x-intercept is going to be positive 16, right? Or I'm sorry, that y-intercept of just this would be positive 16. But then you're multiplying it by that negative 2, and then you have this minus 2 at the end there for that whole function. So just be a little careful. I suggest just going ahead and plugging 0 in for x, just to be safe that you don't miss anything. So if I plug a 0 in here, I get negative 4 squared, negative 4 squared, that is 16, right? Times negative 2 is negative 32, minus 2 is negative 34. So this is 0, negative 34. Okay, so just be careful with that there. All right, and then it says tell which direction the graph opens. The graph opens down because that a value is negative, okay? Kind of like when we were in standard form and we determined if the graph opened up or down. It's based off of that a value of the quadratic function, okay? So the graph opens down because a is negative. All right? Okay, that's it, guys. Go ahead and start your homework. Let me know if you have any questions. See ya.